When working in cybersecurity automation, one of the most critical and recurring tasks is reading, parsing, and comparing dates and timestamps found in log files. Whether you're analyzing an Apache web server log, a firewall alert log, a system authentication log, such as /var/log/auth.log on Linux, or any other security-relevant record, almost every entry is tagged with a date and time. Understanding how to manipulate these timestamps programmatically in Python is therefore an essential skill for a cybersecurity specialist. In this course, you will learn what timestamps and date objects are in Python, which modules to use, how to parse raw date strings from logs, how to compare and compute differences between dates, and how to format dates for output in security reports. Why dates and timestamps matter in security logs. Security log files are chronological records of events. Each line typically contains a timestamp that tells you exactly when an event occurred. For example, a brute force attack attempt will generate multiple failed authentication entries over a short period of time. To detect this pattern automatically, you need to be able to read each timestamp from the log line, convert it from a raw text string into a Python date object that can be compared mathematically, calculate the difference between consecutive timestamps, detect anomalies such as many failed attempts within a few seconds. Without proper date manipulation, you would only be able to read log lines as plain text, which makes automated analysis extremely difficult. The datetime module in Python. Python provides a built-in module called datetime that contains all the tools needed to work with dates and times. You do not need to install anything extra. To use it, you import it at the top of your script. From datetime, import datetime. The datetime module provides several classes. The most important ones for log analysis are: datetime represents both a date and a time, year, month, day, hour, minute, second, microsecond. Date represents only a date, year, month, day. Time delta represents a duration or difference between two datetime objects. Time zone, used to handle time zones. For most log analysis tasks, the datetime class and the time delta class are the ones you will use most frequently. Getting the current date and time. To get the current date and time, you use the now method of the datetime class. From datetime, import datetime. Current equals datetime.now print current. This will print something like March 15, 2024 14:32:07.4583221. The output follows the format: year, month, day, hour, minute, second, microsecond. You can access individual components of the datetime object. Current.year gives 2024, current.month gives 3, current.day gives 15, current.hour gives 14, current.minute gives 32, current.second gives 7. This is useful when you want to compare a log event date against the current time to determine how old an event is. Parsing date strings from log files. In real-world log files, dates are stored as text strings, not as Python objects. To manipulate them, you must first convert these strings into datetime objects. This is called parsing. Python provides the streptime method, which stands for string parse time, for this purpose. It takes two arguments. 1. The string containing the date. 2. A format string that tells Python how to interpret each part of the date string. For example, a typical Apache access log entry looks like this: 192.168.1.10 March 15, 2024 to 14:32 and 7 seconds plus 0000 get/admin http:/1.1401512. The date portion is March 15, 2024 to 14:32 and 7 seconds. To parse this with streptime. From datetime, import datetime. Raw_date equals March 15, 2024 to 14:32 and 7 seconds. Parsed_date equals datetime.streptime raw_date %d/%b/%y:%h:%m:%s_print parsed_date. This gives March 15, 2024 14:32 and 7 seconds. Here is what each format code means. %d, day of the month as a zero padded number, 01, 02, 31. %b, abbreviated month name, Jan, February, Mar. %y, 4-digit year, 2024. %h, hour in 24-hour format, 00 to 23. %m, minutes, 00 to 59. %s, seconds, 00 to 59. Another very common format found in Linux system logs, such as /var/log/syslog, looks like this: March 15, 14:32 and 7 seconds. To parse this format, raw_date equals March 15th 1432 and 7 seconds. Parsed_date equals datetime.strep_time raw_date, %b%d%h:%m:%s. Note that this format does not include the year, which is a common limitation of older Unix log formats. In this case, you may need to manually add the current year to the parsed object. A third common format, especially in modern structured logs and security tools, is the ISO 8601 format. 2024-03-15 T14:32:07. To parse it, raw_date equals 2024-03-15 T14:32:07. Parsed_date equals datetime.strep_time raw_date, %y%m%dt%h:%m:%s. Mastering these three formats covers the vast majority of security log timestamp formats you will encounter in practice. Comparing two datetime objects. Once you have parsed timestamps into datetime objects, you can compare them directly using standard comparison operators. Less than checks if one date is earlier than another. Greater than checks if one date is later than another. Equal to, equals, checks if two dates are exactly the same. Example. From datetime import datetime. Date 1 equals datetime.strep_time March 15th 2024 1432 and 7 seconds, %y%m%d%h:%m:%s. Date 2 equals datetime.strep_time March 15th 2024 1432 and 45 seconds, %y%m%d%h:%m:%s. If date 2 greater than date 1, print date 2 is more recent than date 1. This is particularly useful when filtering log entries to only keep those within a specific time window, for example, only the events that occurred in the last 24 hours. Calculating time differences with time delta. Subtracting one datetime object from another gives you a time delta object, which represents the duration between the two moments. Example. From datetime import datetime. Date 1 equals datetime.strep_time March 15th 2024 1432 and 7 seconds, %y%m%d%h:%m:%s. Date 2 equals datetime.strep_time March 15th 2024 1432 and 45 seconds, %y%m%d%h:%m:%m:%f and d1. Print difference. Total_seconds. The first print gives 0 hours and 38 seconds, 38 seconds. The second print gives 38.0. The total_seconds method is extremely useful in security analysis. For example, if you detect 10 failed login attempts and the total duration between the first and the last is less than 5 seconds, you can flag this as a likely automated brute force attack. You can also create time delta objects manually and use them to add or subtract time from a datetime object. From datetime import datetime, time delta. Now equals datetime.now1_hour_ago equals now, time delta hours equals 1 print 1_hour_ago. This is used, for example, to filter only the log entries from the past hour. Common parameters for creating a time delta object. Time delta seconds equals 30, 30 seconds. Time delta minutes equals 10, 10 minutes. Time delta hours equals 2, 2 hours. Time delta days equals 7, 7 days. Formatting datetime objects as strings for reports. When you produce a vulnerability report or a log analysis summary, you often need to convert a datetime object back into a human-readable string. This is done with the strofttime method, which stands for string format time. It is the reverse of strep_time. Example. From datetime import datetime. Now equals datetime.now formatted equals now.strofttime %d/%m/%y at %h:%m:%s print formatted. This could produce March 15, 2024 at 1432 and 7 seconds. You can customize the output format freely using the same format codes as strep_time. This is useful when your security report must follow a specific date format for clarity or compliance. Unix timestamps. In many security tools and network packet captures, timestamps are stored not as formatted strings but as Unix timestamps. A Unix timestamp is simply an integer, or a floating point number, that represents the number of seconds elapsed since January 1, 1970 at 0 o'clock, Coordinated Universal Time. This reference point is called the Unix epoch. For example, the Unix timestamp 1,710,510,727 corresponds to March 15, 2024 at 1432 and 7 seconds. To convert a Unix timestamp to a datetime object in Python. From datetime import datetime. Unix_TS equals 1,710,510,727. dt equals datetime.from timestamp Unix_TS print dt. This prints, March 15, 2024 14:32 and 7 seconds. To do the reverse, converting a datetime object to a Unix timestamp. From datetime import datetime dt equals datetime.streptime March 15, 2024 14:32 and 7 seconds. %y%m%d%h:%m:%s, Unix_TS equals dt.timestamp print Unix_TS. This prints 1,710,510,727.0. Unix timestamps are very practical for comparisons because they are just numbers. Comparing two Unix timestamps to check which event happened first is as simple as comparing two integers. Time zones and coordinated universal time. Log files collected from different servers around the world may use different time zones. If you do not account for time zones, comparing timestamps from two different sources can lead to incorrect conclusions. For example, concluding that an attack happened before its trigger when in fact the clocks are simply in different time zones. Python's datetime module supports time zones through the timezone class. The most important time zone for security analysis is Coordinated Universal Time, often noted as UTC, which is the universal reference point. To get the current date and time in UTC. From datetime import datetime, timezone. Now_UTC equals datetime.nowTimezone.UTC print now_UTC. This prints something like, March 15, 2024 14:32:07.458321 plus 00:00. The plus 00:00 at the end confirms that the time is in UTC. As a best practice in security automation, always normalize timestamps to UTC before comparing logs from multiple sources. This avoids time zone-related analysis errors. A practical security example. Detecting rapid failed login attempts. To bring all these concepts together, here is a practical example. Suppose you have a small portion of an authentication log with the following entries. March 15, 14:32 and 1 second server SSHD. Failed password for root from 10.0.0.5. March 15, 14:32 and 3 second server SSHD. Failed password for root from 10.0.0.5. March 15, 14:32 and 4 second server SSHD. Failed password for root from 10.0.0.5. March 15, 14:32 and 5 second server SSHD. Failed password for root from 10.0.0.5. March 15, 14:32 and 6 second server SSHD. Failed password for root from 10.0.0.5. Your Python script should 1. Extract the timestamp from each line, parse it into a datetime object. 3. Check if multiple failed attempts occurred within a short time window, for example, 5 attempts in under 10 seconds. The extraction step would use regular expressions, a topic you have already covered, to isolate the date portion of each line. Then streptime converts it. Then time delta comparisons detect whether the time between the first and last event is below the threshold. This is a concrete real-world security automation task that combines your skills in regular expressions, data structures such as lists, and now date manipulation. Summary of key points. The datetime module is built into Python and requires no external installation. Use datetime.now to get the current date and time. Use streptime to convert a date string from a log into a datetime object by providing the correct format string. Use strofetime to convert a datetime object back into a formatted string for reports. Subtracting two datetime objects produces a time delta object representing the elapsed time. Use total_seconds on a time delta to get the difference in seconds as a number. Unix timestamps are integers counting seconds since January 1, 1970. Use from timestamp to convert them to datetime objects, and timestamp to do the reverse. Always be aware of time zones when comparing logs from different systems, and prefer working in Coordinated Universal Time for consistency. The most common log timestamp formats are the Apache format, day/abbreviated month/year/hour/minute/second, the syslog format, abbreviated month/day/hour/minute/second, and the ISO 8601 format, year/month/day/hour/minute/second.